On 22 from the 1-2 review sheet, Unit 1-2 review sheet, we're given the function value sine of theta equals 2/3 and want to determine the other 5 trig functions. And it's an acute angle theta, which means we can use a triangle. So a diagram will help here. So let's make some straight lines actually. So I'm going to just draw a triangle with a right triangle with an acute angle here. Let's call this one theta. And sine will be opposite over hypotenuse. So that means this side is 2 and this side is 3. Right, that's SOHCAHTOA. So I'm using sine so far, so that's sine of theta equals opposite over hypotenuse. Okay, so that gives us the 2/3. That's what we were given already. Now to find cosine of that angle, I want the adjacent. So I need to find that third side. So to do that, I'm going to use Pythagorean theorem. I'll call this side A, and we'll say A squared plus, let's call this side B, and this side C. A squared plus B squared equals C squared. And we're solving for A. So I'm going to subtract B squared from both sides and take the square root to get A. And it'll be a positive A because it's a side of a triangle. So that's the distance. So we have square root of C is 3. B is 2. That leaves me with the square root of 9 minus 4, which is the square root of radical 13. And that is prime. So, wait, that's not correct though. Sorry. 9 minus 4 is 5. And that is prime. So that is as simple as we're going to get it. So we have this side equals radical 5. Okay, so our cosine is going to be adjacent over hypotenuse. So that's radical 5 over 3. And our tangent is opposite over adjacent. So that is 2 over radical 5. Secant is the inverse of sine. So that's 3 over 2. Cosecant is the inverse of sine. Secant is the inverse of cosine, so that's 3 over radical 5. And cotangent is the inverse of tangent, so that's radical 5 over 2.